Hello, hello, good morning. It's great to be in Barcelona. I know I'm the last thing before the next coffee break, so please bear with me for another 30 minutes. What are we going to talk about? We want to talk about the Edge. I think I missed one slide, yes. So I want to share with you a little bit about Wasm at the Edge, kind of state of the union, and I want to share with you a practical use case that we have in production today at Edgee. I really loved Eduardo's quote earlier this morning about trying to sell solutions based on Wasm instead of selling Wasm directly, and I think that's exactly what we are doing. So happy to share a bit more about that. And nice to meet you all. I'm Alex. I'm a software engineer from Italy. I've done a bit of work in the startups, and then I work at AWS for 6 years, and today I'm a developer advocate at Edgee. We are a small startup of 10. Fully remote across Europe, so you can meet us at the booth as well. So I want to start by having a look at clarifying what's the Edge. I know many of you already know it, but I want to make sure everybody's on the same page today. So it's quite a wide umbrella term for a lot of different things. If you're a web developer like me, you probably think about CDNs and CDN providers allowing you to run compute on top of their edge networks, and that's great. There are another 10 different ways to think about the edge, like IoT devices or smart factories or smart manufacturing. That's not what I want to talk about today. I want to stick to the web world, as I guess many of you are from that background as well. I wanted to go through a lot of cloud history and internet history. I don't think we have a lot of time to go through that, but it's basically a history of the internet and how it kind of became the cloud in the last 20 years. Why do you need this to understand the Edge? It's because it's all connected, and there is a nice pattern as we went from bare-bone virtualization to virtual machines that could spin up in minutes. That's very different from ordering a server in the 2000s and getting it 3 months later. And then we went from virtual machines to containers, then we went from containers to serverless functions, and that was 10 years ago already, if you can believe it. Lambda was born in 2014, 2015. Big fan of that. Now these vendors are just pushing AI, but that's a story for another conference. Another thing that really evolved in the same time span in the last, let's say, 7, 8 years, almost 10 years, is the CDNs world. They were born as content delivery networks, DDoS protection kind of services, and some of these companies are as old as Google. That's a new thing that people say these days. But these also evolved, and they started including compute at the edge capabilities, between the 2015, 2019 years, so still fairly recent. And when you start having compute at the edge, it's not enough. You also need data services, you need databases, you need key value storage, you need configuration management, you need all that stuff that real applications need in production. And another thing that came up even more recently is Wasm support. So some of these support Wasm a bit more, a bit better, some a bit worse. Akamai doesn't support it pretty much at all. CloudFront, not officially. Some people managed to run some Wasm on top of Lambda at Edge. Cloudflare and Fastly have some better support, so let's dive a bit deeper into that. If we look at Cloudflare, they have some good support, for the JavaScript side of things, because that's where they were born initially, to solve those problems. They have some beta support for Python. They do some cool stuff with Pyodide and some, memory snapshotting magic to help you with performance. They also have some beta support for Rust, but still no real support for, the component model or some of the more recent WASI stuff. Fastly, a bit better support built in. When they launched Compute at Edge, it was running on, with Wasm natively, so they have some good SDKs for a lot of languages and some unofficial ones. And you can even build your own, because all the WIT files are available and so on. But still only WASI P1, and if you talk to the great Fastly people, they'll tell you P2 might come soon, but it's still not there. So we are using Fastly today, and we are finding our own ways to work with the component model. I'll share more about that later. A useful difference when you go to the edge, compared to the traditional cloud model, is that you are globally distributed by default, and that's a fun thing to be able to do as a developer, because typically cloud architectures start as monolithic, one cluster or one data center, and eventually you can go multi-region, eventually you can go global, but with the edge, that's the default. Your application is running on top of hundreds of edge locations, all distributed around the world by default. And that's a pretty cool advantage. Of course, it comes with some drawbacks, because you don't have infinite resource, you don't have infinite amount of resource, and you have some performance constraints. I'm also sharing some Fastly and Cloudflare data. Like you have 50 milliseconds, in some cases up to a few seconds if you have a paid plan on Cloudflare. You have some memory limitations, you have some limitations about lookups or origin requests that you can handle. So there are some interesting constraints to keep in mind. There are some ways to work around that, and some of the edge providers, such as the Bunny.net or the Akamai, are trying to push a container-first model to go around some of these constraints. But it's still very, very early. And there are some very well-known benefits of WebAssembly that you all are aware of that are really, really handy when it comes to the edge, in theory, because at the edge you need to be really fast. You want to run your application logic in less than 5 or 10 milliseconds. Otherwise, you're just adding latency to pretty much every request, and that's a problem. You would appreciate the fast startup time because you cannot afford seconds and seconds to spin up your component or your app. And you really love the sandboxing that Wasm provides, because often, and that's true for us, you want to be able to run third-party, untrusted code if you want to provide your customers a way to customize the service or implement their own business logic. So this is really promising on paper. There are still some obstacles, as we'll see. Now, let me share a bit more context to let you understand why we need Wasm at Edgee and how we are using it and what kind of problems we are trying to solve. In a nutshell, we are trying to build a platform of application-level services for developers, powered by the Edge and powered by Wasm. So this is the core problem that we're trying to solve. In a few words, we're trying to help companies get rid of some of the super heavy client-side SDKs. If you didn't know yet, the average website has over 30 third-party SDKs or JavaScript scripts integrated into their HTML pages. On average, that's 1.5 seconds of blocking time, and that's a problem. Just to integrate data collection, behavior analytics, conversion APIs, attribution, and all the things that you typically want to do on the browser, because if it's a button click, there is no other way to track it unless you actually run something on the browser. And for us, the final goal is to transform those client-side SDKs, which suffer from a lot of limitations, including ad blocking, network issues, and JavaScript compatibility issues, and transform those into WebAssembly components that we can run directly at the edge and take care of all those tasks instead of in the browser, directly at the edge, talk directly to the analytics provider, talk directly to the attribution APIs, talk directly to the cloud, storage or data warehousing APIs like S3, Kinesis, and so on. How do we do that, and why do we do that with Wasm? Well, we settle on some interesting and bold vision and mission, and we want to empower developers to build the next gen of sustainable applications. And to do that, the mission we came up with is we want to build an open source ecosystem of open source components powered by WebAssembly, so that they can run whatever they are most effective. And today, for us, for this kind of challenges, that is the edge. Some challenges we needed to solve. We want to be able to run this business logic very efficiently, because again, this is running at every single HTTP request, so it can't take 5 seconds. It needs to take 10 milliseconds, so we need speed. We want to support untrusted code, so we need some secure sandboxing, and that's probably the main reason we are using Wasm. we needed to define some domain-specific interface. So we needed some, WIT-like way to define our interfaces, and also find ways to handle the versioning for both the third-party components that we want to host and for the WIT interfaces themselves. So there is some versioning versioning madness we need to handle. And that's why we settled around 3-4 months ago. We sit down and we started building the Edgee component registry. That's an open registry that anybody can use to push their Wasm components and use them, implement the WASI interface that we provide for different categories of services, like data collection or A/B testing or security firewalls. And then push to this component as a public or as a private component. And then we make sure you can run that in our managed platform. Or you can use the open source proxy and deploy all this stuff as an open source solution on your own infrastructure. That's also possible. This is what we have today. There are about 20-25 components available, most built by us, but the idea is to open this up, and it's already open, to anybody who wants to push a Wasm component to this kind of registry. We have a big roadmap of over 100 components that we want to to build and make available later this year. Most of these are in the analytics, data warehousing, attribution space, but we'll soon expand into new categories and new types of components, again, like security, AI inference, and many more things. A bit of a technical review about what we actually decided to do in the end. So we have this kind of reverse proxy that we implemented in Rust, again, for performance, for type safety, and so on. This is, in practice, a thin layer, domain-specific layer on top of Wasm time. So we are using Wasm time to run the components, and then we add this layer to handle the specific WASI interfaces and the different types of components that we need to manage. And this is all open source, so you can check it out. We have a shared code base, all in Rust, for the open source proxy and for the CLI that you actually use for building and deploying locally and testing locally and so on. Check it out on GitHub. We also define our own WIT interfaces and types and everything we need to allow developers to implement exactly the interface they need to implement the business logic. So we define our package, our world, and many different types of components there. In theory, we are trying to hide all the WIT complexity. So again, with the idea of selling a solution, not just selling you the Wasm dream. And so if you look at the Wasm components and the CLI, we are hiding all the WIT complexity. We initialize the worlds for you. We hide as much as possible. So as a developer, you only focus on the business logic. We are already supporting all of the WASI P2 support languages, at least the official ones. So you can easily get started with any language that you want and then push to a registry, and we take care of everything else. So we support Rust and Go and C, C#, Python, JavaScript, and TypeScript. As you can imagine, the compiled ones are so much more efficient and small, like hundreds of kilobytes, even less. If you push a Python component, that's going to be like 30 megabytes, and it's super slow to load. But some of the things that we're doing can actually run asynchronously, so it's not a big deal. Like we run in the background somewhere else, not directly at the edge, where we have 50 milliseconds of time availability. So I'll show you later how to spin up a new component with the language that you want using the CLI, but all the repositories are actually public as well, so you can check it out. And we'll probably add more in the future. All of this is integrated with the managed service. So when you push a component to registry, we automatically make sure it's available to any Edgee customer. So with one click in the Edgee dashboard, they can enable that specific component in their Edgee projects. So it's all managed. But again, you can take the open source stuff and deploy it for your own in your infrastructure. This is how we define the world, for example, for data collection. This is all about analytics and sending data around. And we define a pretty precise data collection interface that allows you to implement the methods that you typically need for managing, the Google Analytics or segment or data going into the analytics provider, like how to handle a page view, how to handle user identify or a custom truck event. So when you generate the code bindings for your own language, you will have all these types and all these code generated for you, and all you need to do really in the component code is implement those three functions. That's all you need to do. So the code itself is very simple and performant. It can run in a couple milliseconds. Also note, the component is not doing the API call to Google Analytics. The component is telling the proxy how to make the HTTP call. So we want to have some control over this. And so the component itself doesn't have any network or file system or any access, and that's what we want in the first place. So we can trust the code, we can run it. If it explodes, whatever, and we'll make sure you can test locally and make sure it's working correctly before pushing. We wanted to provide a great developer experience, so we built a CLI tool for local development, local compilation, and local testing, and then you can use the same tool for pushing. There are a few ways to install it. This is all open source again. Let me show you how that works. I wanted to do a live demo, but I wasn't sure about timing, so I ended up recording a 1-minute video, so nothing fails, hopefully. So you can just create a new component locally, provide a name, provide the language that you want, and then we manage behind the scenes all the weight complexity. You implement the business logic and build. We handle the build complexity for each language, so you don't really have to be aware of all the details for your own language. This is a JavaScript example, but the same is for all the others. And when it's time to test, you can just test locally. You provide some parameters. You can even ask the CLI to actually run the HTTP calls for you and maybe test in a staging environment. And when it's time to push, you just Edgee component push with your Edgee credentials. And everything gets pushed as a private or public component. It becomes available immediately in production. There you go. Super. So how does the architecture look like? Because I promised we were doing some Wasm at the edge. Now, ideally, what we wanted to do, at least at the beginning, was to can I do this? Yes. Was to be able to run the Wasm directly at the proxy level running on Fastly, because the Rust application that we run on Fastly is already a Wasm module, and that's how the Fastly compute platform works. We couldn't really do that, so we went creative and found a different way to do it, especially for the data collection stuff that we're doing. This can run asynchronously. We don't need to wait for the response to be able to serve the HTTP response. So what we ended up doing is create our own API to run these things, and we wanted it to be resilient, reliable, efficient, even though asynchronous. We want to make sure it runs in just a few milliseconds, and the data collection is real time, so all the events pop up in just a second or two, not more. And that's why we are going multi-region. So this API is running on top of AWS Lambda. So what we do in the Lambda runtime is getting all the requests in the right region as close as possible to the Fastly edge node. We get the request, we see who you are and what project and what component version you need. We download the Wasm, we kind of hot load and instantiate it right there. This might take a while if it's a Python or a JavaScript, but it's OK, because it's all asynchronous. And so in every region, and even in every availability zone, you hot load the right component that you need and run it. And then you talk to the right APIs and so on. So this is all running on AWS today. We are going, basically, because of the edge limitations that we are encountering, we are ending up building our own globally distributed infrastructure to run the Wasm components. So today it's running on Lambda. In the future, it will run on more clouds. And ideally, in a longer, distant future, it will run directly at the edge as well. But for now, we are OK for some of these workloads to use some edge and some cloud. Of course, there are other components of the architecture. We have our own API, there are registry APIs. There is a console running on Versal, some CLI that you can run locally, and possibly you can use the Edgee API to do some automation yourself. Some of our customers are going to do that as well. So what do we learn, and what are the next steps for us? If you've never used CDN or a compute at Edge, check it out. CDNs are not just for caching and DDoS protection. Maybe that's what you had in mind based on the last couple of decades of content delivery. There is a lot more happening. We think that edge computing is one of the ways that you can build new applications and add new features to existing applications without having to refactor or replatform. We think Wasm and WasmP2 are very promising, even though there are a lot of limitations right now at the edge, and we are trying to find ways to overcome them with creative solutions, building our own network of distributed Lambda functions or other ways, maybe it could be containers as well. We wish, and this is a problem we haven't figured out how to solve, happy to discuss if we have a solution, how to manage the multi-version problem at the width level for the host, because the guest always has one specific version in mind, and they build for that. But as the host, we need to support multiple width versions, and that's creating a lot of complexity. You have to import multiple worlds with the right version and use the right version based on the component that we are getting. So if you have a solution, I'm here to learn as well. Happy to discuss and share some lessons if you worked on that before. I have a couple of call to actions, and then we have a lot of time for questions and the coffee break. Join our community. It's open. It's all open source. Check out the registry. It's super easy to push a component, and maybe you have an API you want to integrate as a private or as a public component. So check it out. It's all free to use. It's very developer friendly. It's well documented. So happy to get your feedback as well. Thank you. I have a big asterisk because we have a booth, so come talk to us today or tomorrow, no rush, during a coffee, or we can show a little demo. And that's all I had for you. Thank you for coming. We have a lot of time for questions, so bring it up. I'll get some water.
I was just... Hello?
Where are you?
I'm over here. At the beginning, you said you were replacing a lot of the client SDKs. Are you running anything actually like on device, or is it all like once it gets to the edge, so to speak?
So the idea is that because everything that runs in the browser can be blocked, like the API call just gets blocked, the network can fail. Sometimes the JavaScript compatibility is an issue. Sometimes privacy and cookie acceptance is an issue because there's like a 33% acceptance rate. So if you don't have the cookie banner, you just can't send any data. So what we're trying to do is overcome those challenges. So we do have something that needs to run in the browser, and that's the Edgee JavaScript SDK. That's super minimal, like 8 or 9 kilobytes. That replace all the SDKs that you would normally integrate. So the Edgee SDK talks to the edge, and then we kind of multiplex the data where it needs to go. We don't store the data. We just send it where you want it to be.
Gotcha. Thank you.
Any other question, guys?
Thanks for the presentation, Alex. My question is, what sort of edge devices do you have in mind?
That's the thing. For now, we are the edge, and we stay between the browser and the origin, or the website that the browser wants to visit. So we are not targeting mobile or IoT devices directly, although that's a direction we want to take in the future and support, not just websites, but it could be the smart IoT world or the mobile world as well. That's a good question, and we get that a lot. So thanks. We have time for one more. Awesome. Coffee it is. Thank you, everybody, again.